GJ Math. So we have now learned to get the inverse, to sketch the inverse, and now we are going to go over to sums where they sketched it for you, but you must interpret the graphs. So in this section, it's more like grade 11 functions, but they are applying a little bit of grade 12. So let's see what you need to know before you can start this section. So whenever they tell you to reflect something in the x-axis, then you put a minus in front of y, but the minus can't be in front of y, so you move it in front of the function. Okay, so if I reflect in the x-axis, put a minus in front of the whole function. If I reflect in the y-axis, I put a minus in front of x. And then many times it's fine, but if it leaves you with a negative exponent, please just make it positive by taking the base down, as you can see the example in the green block. Okay, so now the new grade 12 things come in when they say reflected around the line y is equal to x. You must please remember that is code word for get the inverse. Okay, so you already know reflect in the x-axis, y-axis, but if they say in the line y equals x, do an inverse. The tip at the bottom, you can just note, I will talk about it now when we do an example. A typical question in your exam might look like question A. So the graph of fx is equal to a to the power x, and that passes through the point minus 2 and 4. Calculate the value of a. So they give me a coordinate, and I know I can just rewrite the fx equals to, I can just change it to y equals a to the power x, and therefore I can just sub in the coordinates. So I can say 4 is equal to a to the power minus 2. To get a alone, I would just multiply by the reciprocal, and remember that just means I need to give each side an exponent that would cancel the a's exponent, because that would leave me with a to the power 1, and if I type this in the calculator, it would give me a half. So therefore a equals a half. Now please, whenever you get that value in big letters and highlighters or whatever, please write for yourself fx is now equal to a half to the power x, so that you know each time they talk about f, I am not going to work with a to the power x, I am going to work with this new value I got. Okay, so except there, many people get stuck because they keep sticking with the a to the power x. Anyway, write down the equation of the inverse f minus 1x. Okay, so now that I know my actual formula, I can just say the inverse of this would be equal to, let me just make this question 2. So I can then say this is x equals a half to the power y. Get y alone again, I would say this is log, base, there's the base, and the other two swap around. So f minus 1x would equal to log a half x. Okay, great. So that is the answer for question 2. Question 3, determine the equation of g, the reflection of f, in the y-axis. To get that answer, I would then take my f equation. I'm just going to say it's y equals to a half to the power x. So now what we learned on the front page. Determine the equation if it is reflected in the y-axis. So I'm going to put a minus in front of x. I don't want to leave it that way with a negative exponent, so this is going to become 2 to the power positive x. And that would be g of x. I'm just going to change it back to g of x. So now question 4. Determine the equation of h if it is a reflection of f in the x-axis. I would take my blue equation again, and I would just put a minus in front of y. Okay, and this stays a half to the power x. Now remember, I can't have a minus in front of y, so I'm just going to move it over to the other side and say it is minus, and this I'm just going to put in a bracket. And that would be the h equation. So there I got all the equations they were talking about. Now question 5 says sketch all of those equations. Now what I'm going to do is I'm only going to do the table method for my original fx function. So what I mean with that is I'm going to say x, I'm going to do minus 1, 0, and 1. And you can do this on your calculator. So you go mode, table, type in the equation, and then start at minus 1, end at 1, step is 1. Okay, so when I type that in, I would see that if it's minus 1, this is going to be a 2, to the power 0 is 1, and then to the power 1 is a half. Okay, so those are my coordinates I'm going to use to sketch the fx function. So what it says is when x is minus 1, y is 2. So I'm going to do a dot there. When x is 0, y is 1, and then when x is 1, y is a half. Okay, my asymptote is the x-axis. So your sketch doesn't need to be perfect. As long as it goes through the coordinates and your asymptote is correct, you will get your marks. I can just label it f. Okay, so now I'm going to sketch all the others. With my inverse, I'm going to take the coordinates of f, and I'm just going to swap x and y each time. So If my 1 dot was at -1 and 2, it would now be at 2 and -1. If my y-intercept was 1, my x-intercept is now going to be a 1. And then my other dot was at 1 and a half, that is going to change to a half and 1. And with everything in inverses, x and y will swap, so the x-axis was my asymptote. Now the y-axis is going to be the asymptote. So if I connect it, my graph would look something like that. And I can label this f minus 1. Okay, so now I can go over to my g equation. And with that one, it just said I reflect everything in the y-axis. So then I'm just going to take all the blue coordinates and I'm going to put a minus in front of x. So what that means is this dot would just move over there. This dot would just move over there. So let's just sketch that. So then this one would be there, there, this one would be at that place, and then I connect all of them. So this time it's taking the blue graph and it's reflecting it in the x-axis. So it just flips downwards. So I would have a dot there, there, and there. My asymptote is still the x-axis, so it just looks like this, and this is my h graph. Okay, so lots of sketching and flipping and whatever. I don't need to do table method for all of them. As long as I have the original, I can just apply the rules as they give it to me. And that is then the answer to question 5. So to answer question 6, I would just say, okay, my domain would just be x is an element of real numbers. And that counts for the blue and the purple graph, for f and g. Okay, so now if I look at the range, the range is y values, and I'm asking, where does this graph start? If I read from the bottom to the top, where does it start and where does it end? So if the x-axis is my asymptote, then the graph starts just above the x-asymptote, or the x-axis. So for the range, I can just say y is greater than 0. You can put a y element of r. Some teachers like that. But as long as you say y greater than 0, you will get your marks. Great. That is the entire question. So a lot is happening on that sketch. But if you do it step by step, they won't catch you out. Just keep track. If you can use colors, that helps a lot. Question B. So yeah, they give you the sketch. And the moment I get a question like this, I'm going to take my highlighters and I'm going to color code everything that I can, just to make it so much easier for my brain to connect when I'm talking about the G and the H and the F. If there's colors and the sketch has colors, it is going to be so much easier. So please take that advice. If you struggle with functions, that will really help you. Then, so determine the value of A. Now I can see A is my blue function, and on the F, the blue function, I can see a coordinate, 3 and an 1/8. And that's what I'm going to use to find A. So I know I can rewrite this as y equals a to the power x, but because they give me a coordinate, I can, in the place of y, I can sub in the 1/8, and then a to the power 3. Now I just cube root both sides, and therefore a is equal to the cube root of 8, which is a half. Okay, great. So now I know my blue graph is going to be y is equal to a half to the power x. Determine the equation of g. Okay, the green graph, and if I look at the info given up top, it says g is the reflection of f in the x-axis. Now remember what we said at the beginning of this video. If you reflect in the x-axis, you put a minus in front of the entire function, or a minus in front of y, and you move it over. So this would then be y is equal to a half to the power x. I put the minus there, but it's not allowed to stay there because y must be on its own. So I'm just going to move the minus in front of the half. There we go. That is my g equation. So for your teacher, you can just go and write g of x equals to negative a half to the power x. And I can put that in a bracket. Okay, give the range of f and g. Okay, so the range of f, you can just say f range. So if I look at the blue graph, range, if I read from the bottom to the top, which y values do I get if I look at the blue graph? So it's just above the x-axis, so therefore it only exists when y is greater than 0. If you want to, you can put y as an element of real numbers. That's it. That is the f range. So now if I look at g, it's just the opposite because it's reflected in the x-axis. So it starts at minus infinity, and then it goes all the way up to 0. So I can say the range of g can be written as y is smaller than 0. So you would notice I don't include the 0 because it's an asymptote. Okay, so just for everyone who likes to write it in the other notation, I can say this one is minus infinity up until 0, both round brackets. And the f graph I can write as y is an element of round bracket 0 up until infinity. Well, determine the equation of h and its domain. So they tell me h is the reflection in the line, y is equal to x. So remember, that is code word for the inverse. I'm just going to take my blue graph and I'm going to swap x and y. So it would be x is equal to a half to the power y. To get y alone, I need to use log. So y is equal to log. The base stays the base and the other two swap around. So the half goes there, the x goes there. Perfect. That is my equation, but now they also ask me for the domain. So something to notice, like I said, in inverses, x and y swap with every aspect. So if the range of the blue function was y is greater than 0, the domain of the inverse now becomes x is greater than 0. So for the domain, I can just say x greater than 0. Or if you want, you can just say x is an element of 0 to infinity. Okay, question 5. Write down the coordinates of A, B, and C. So remember, I am just going to work out A, my original, and then I'm just going to switch coordinates and put minuses and everything. So to work out A officially, I can say y is equal to a half x was my function, and A is when x is equal to 0. So then it would be y equals to a half to the power 0, and anything to the power 0 is just 1. So therefore A has the coordinates of 0 and 1. Okay, so B was the reflection around the x-axis. And if I reflect around the x-axis, I just put a minus in front of y. So B would also still remain at 0 for the x value, but the y value would be minus 1. Okay, so now for C, it is the inverse. And to get the inverse, I swap x and y. So I'm always working from my original, the blue function. And if I swap x and y, this would become a 1, and that would become a 0. And there I have the 3 coordinates. And I only worked out the first one, and then I reflected to get the others. Okay, it just saves so much time if you are limited for time in an exam. Question 6. Determine the image of P, which is the P coordinate inversed. Okay, because it's on the H graph, which is the inverse of the other one. So I just swap x and y, and that's how I would get it. So that little dot there means the image of P. So the coordinates would just be an eighth and 3. There's no calculations, nothing I need to show. I just need to write it like that, and then they'll know, oh, okay, this guy knows to swap x and y. Okay, now we get to the advanced questions with the inequalities and everything. So, for which values of x would the y value of f be less than 1/8? Okay, that sounds very complicated, but let's just look at this logically. So the question asks me, where does the blue graph go below 1/8? So if I look at my sketch, I can immediately see it's there at point P. Now, the only thing I need to write down is it left of P or right of P? So obviously, if they ask me where does it go below, it can't be left of P. It can't be less than 3. So therefore, the answer would just be x must be greater. So remember, I'm not putting a equal sign there because the question didn't have an equal sign. And then I just say it's when x is greater than 3 to the right of point P. Question B, so where does the green graph lie between -1 and 0? If I look at the y values, where's the y values between those two, -1 and 0? And my answer must be in terms of x. So in question 5, we found that B has a coordinate of 0 and -1. Okay, so I know it's something to do with B, and its x value is 0. So my answer must be something with 0. Now I must just see, are they asking me where does it go below or above? So it's clearly where it is above because it must be between -1 and 0. And that happens to the right side of B, which is there. Okay, so I can write that as x would lie between 0 and infinity. Okay, but a better way to write that is just x is greater than 0. Okay, so whenever you get questions like this, they are asking you to look at the y values, but answer in terms of x. It's quite confusing if you're not used to this, but with more practice, it will be really easy. Okay, the question C. So for which values of x would the log graph be greater than 3? And so this question, I'm going to use the answer for question 6, which says this image of P had a coordinate of 1/8 and 3. So if they ask me where does this purple graph go above 3, I can just see, okay, so my answer is going to be 1/8, something with 1/8. So I must now just decide, is it bigger? Is it to the right of that point or to the left of that point? And it goes up to the left of point image of P. Okay, so the answer must then be x lies between 0 and 1/8, because remember there's an asymptote. So this purple graph does not exist on the left of the y-axis. So I can't say it's just smaller than 1 over 8. It must be between the asymptote and 1 over 8. Okay, guys, we ended on a really complicated note, but I hope it makes sense. If it doesn't, please leave me a comment and I'll do a special video just on these inequalities. But the rest of it I don't think was too bad. It's only question 7 that was a bit challenging.
If this video helped you, please like and subscribe.
JJ, man!